Ya, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Daniel bin Muhammad Araha. So in this video, I will be talking about my CM589 research methodology assignment 3 on the topic of a study on soil stabilization using industrial waste materials in soft soil clays. So moving on to the introduction. Soft soil clays are problematic due to high compressibility and low strength. Its infrastructure projects on soft clay face settlement and failure risk, with traditional stabilizers like lime cement are mostly costly and environmentally harmful. Industrial waste materials offer a sustainable alternative. For the research area, the field is in geotechnical engineering, which it involves studying on soil and rock behavior to support safe and effective design in construction. This research falls within the subdiscipline of ground improvement, which focuses on enhancing the engineering properties of weak or problematic soils like soft clay. It focuses on ground improvement for weak soils. Ground improvement techniques are essential when natural soil conditions cannot support support these structures. This study specifically aims to improve that the composite strength, shear resistance, and plasticity characteristics of soft clay, a common weak soil found in many tropical regions. The sustainability in this research is using industrial ways for soil stabilization. Instead of relying on conventional chemical stabilizers like cement or lime, which are energy intensive and polluting, this research explores the use of industrial waste materials. This promotes sustainable engineering practices by minimizing environmental impact and supporting circular economy principles. Key materials is fly ash, bottom ash, and GGBS, where fly ash is a byproduct from coal combustion with pozzolanic properties that can enhance soil strength, and bottom ash, which has heavier residue from coal combustion, also effective in soil reinforcement, where GGBS is granulated blast furnace slag, a waste from steel manufacturing, from that reacts chemically with clay to form cementitious compounds. Moving on to the research problems, where the construction on soft clays leads to excessive settlement and instability, and the traditional methods have high costs and carbon dioxide emissions. Limited data on performance of industrial waste for stabilization, and it is need to for comparative analysis under various mix ratios and curing times. One of the research questions are what is the effect of different industrial waste materials on soft soil clay, which waste type provides the best strength over time, and how does the waste proportion influence soil strength. There are three research hypotheses in this research where waste additives increase strength and reduce plasticity. One waste type will perform best across the curing periods. Strength improves with dosage up to an optimum ratio. The research objectives are characterize properties of untreated clay and waste materials to evaluate how waste types and ratios affect strength and plasticity, and to determine optimum curing time for maximum strength. The scope of study is basically like before, materials, which is include fly ash, bottom ash, and GGBS, while the test includes attribute limit test, UCS, and compaction to evaluate the effectiveness of stabilization, where attribute limits determine soil plasticity by by determining liquid limit, plaster limit, or plasticity index, where the variables for the additive is in percentage and curing time is in between 7 to 28 days, where the study varies the percentage of industrial waste added to soft soil clay. This is a lab-based study which no field trials for or long-term durability, and all tests are conducted in a controlled laboratory environment. The significance of this study is to identify viable alternatives for weak soil stabilization and to reduce industrial waste that promotes sustainability, which lower project costs using waste materials and to, contributes new data on soil waste interaction. That's all from me. Thank you very much.